Good afternoon, my name is Stan Forrester and we're going to be working with the DC construction circuit kit. Okay, we're going to be trying to confirm Kirchoff's voltage law, which is, or the loop rule, and Kirchoff's current rule, or the junction rule. Okay, so let's start with a battery here, set her upright, just because I kind of like them that way. And then we'll take a wire here, and let's take a couple resistors here. 1, 2, 3, and let's go ahead and let's connect those up. Connect that up there, and then we'll move down here. I'm going to take an ammeter, and we're just going to provide a current, one single loop here, one single loop. All right, and so let's ask ourselves, okay, so what's the sum of the voltages around here? Like for instance, okay, so we have these blue indicators for electron flow. Remember that current flow would be in the opposite direction. We would imagine that this charge transport is being done by positive charges, and so it would go in the opposite direction. So let's go ahead and let's measure up what the potential difference is. The rise across this battery is 9 volts, and if we're going to have any kind of conservation of energy in this, or energy per unit charge, in other words voltage, we have to somehow or another have this return back to 0. So this is 9 plus a -3 plus another -3 plus another -3, and so 9 plus 3 plus, 9 take away 3, take away 3, take away 3, and that does indeed give us a loop, sum around that loop equal to 0. Alright, let's play around with this a little more. Let's disconnect that. Let's see what happens if we put another resistor in here. Let's put another resistor in there, and then we want this here to still be part of the thing. Okay. Actually, it may be a little confusing there, so I'm going to do this, and I'm going to actually put an actual wire in there. All right. Okay, so we have a couple different loops. We have this loop that goes all the way around the outside, just like we had before. We have this loop that goes around this top loop. We also have this loop that goes around this bottom loop. All right, so let's see what we have there. Let's just do that bottom loop there. Okay, so this is minus 1.29 volts, and then I'm going to follow this around. Put this here. I'm going to put this on the other side, and 1.29 volts, so this is negative 1.29 volts, and this is positive 1.29 volts. Yeah, that loop there is 0. Yeah, let's talk about around here. Okay, so let's start our battery again. I expect the battery is somewhere or another. I lost the ammeter. There we go. Okay, I expect the battery is probably still going to be 9 volts. Yep, still going to be 9 volts. What's going to happen here, though, because I've got more battery, I got more resistors. Okay, this is minus 2.57 volts. Minus 2.57 volts. Minus 2.57 volts. Let's keep going. Let's keep going around. And minus 1.29 volts. Well, we saw that before. Okay, the question is, when you add up all of those signed values, positive 9, does that add up to all of the negative drops that we saw around this loop here? Okay. Second one. Let's go ahead and let's get rid of this one here. Let's see, an ammeter current. Let's go ahead and this is 1.3 amps coming into here. So we have 1.3 amps coming into this. 1.3 amps coming into this here. Is that going to be equal to the current that's leaving? 0.26 amps. And you can test that at a couple different places as well. Okay, hopefully that gives you an idea how to get started, how to do all this. Please see me in the discussions if you have any questions on how to do any of this or measure anything. Okay, bye.